Hi Math 1, this is Miss Van Vickle, and this is the 3.1 Ready, Set, Go video that I prepared for you. The Ready part of the Ready, Set, Go has us graphing some functions, and it asks us to find 3 points that lie on each graph, and then we have to choose a scale for our graph so that we can put all 3 points on the graph. And I'm lazy, so I used my calculator to find points on the graph, and I graphed my function in my calculator, and unfortunately my camera is not picking up the graph on the screen. But if you go to your y equals screen and you put in negative 2x plus 5, so I'm going to show you those keystrokes, negative 2x plus 5, and you hit graph, you should see the graph of a line. It looks like it's decreasing from left to right. And then if you hit second graph, it'll pop up the table. And I noticed that there is a point at, let's see, let's do some negative numbers, at negative 1, 7. So I'm going to write that on my paper. There's also a point at 0, 5. And there's a point at 1, 3. So I'm going to write those points down. They came right out of the table in my calculator. And now I have to choose a scale for my graph that makes it possible to graph all 3 of these points. And what I notice is I have 10 little lines going up and 10 going across. And I need to span negative 1, 0, and 1 in terms of my x values going across. But I also need to go from 7 to 5 to 3. So I'm going to go ahead and I'm going to put my axes kind of in the middle of the graph. Because I have negative x values. I don't have any negative y values, but I've got negative x values. And I'm going to say if each one of these marks is 1, then that would put us at 1, 2, 3, 4, 5. And that's a problem because I have a y value that's 7. So I'm going to make them 2. And I'm going to indicate my scale by labeling right here that that's 2. So this would be 2, 4, 6, 8. So if I take a look at this first point, it's going to be at negative 1, 2, 4, 6, and 7 would be kind of right in the middle. So that's where that first point would lie. Then I have a point at 0, 5. So I go 0 on my x-axis, but I need to go to 5 on my y-axis. So that's going to be 2, 4, and there's 5. And then I have a point at 1, 3. So 1, and then if I'm going up, there's 2 and 4. 3 would be kind of in the middle. Not kind of, exactly. And then I can connect my points, and I see that it's a line. And it looks very much like the line that I have in my calculator. So I've graphed number 1 for you. I'd like to do number 6 with you just because it's a little bit different. You'll notice when you graph it, it's not a line anymore. You get a curve. So let's take a look at the keystrokes we need to graph number 6. 8 times, so I'm going to put 8 and then the times button, times 3 to the x power. Notice x is in the exponent. I use the caret button to get up to the exponent, and then I put my x in. And now I can graph that function. And I see that it kind of hugs the x-axis for a long time, and then it shoots up and gets really big really quickly. So I'm going to use the same strategy. I'm going to do second table, and I'm going to take a look at the values that my calculator found. And I'm going to choose a negative and a 0 and a positive. So I notice at negative 1, I have a point at positive 2.6 repeating essentially. And I notice at 0, I have a point at 8, and at 1, I have a point at 24. So again, I think I'm going to have to be careful about the scale that I use for this because my y value gets very large very quickly. And if I'm not careful, I won't be able to fit this 24 on the graph. So let's go ahead and I suppose put our axis a little lower and maybe a little bit over. And then let's see if I can get 24 on here. If I went 2, 4, 6, 8, 10, 12, 14, 16, 18, that would follow the logic that I used in the first one, but it doesn't get my 24 y value on there, 1 and then all the way up to 18, and that doesn't work. So I'm going to have to figure out a different scale. I could use 5, 10, 15, 20, and that would work. So why don't we go ahead and do that? I'm going to have a different scale on the x-axis than I do on the y-axis. I'm going to do 1, 2, 3, 4, 5 on my x-axis, and on my y-axis I'm going to do 5, 10. Sorry about that. That's Zuzu barking. That's the scale I'm going to choose on my y-axis. I'm counting up by 5s. So -1 and a 2.6 repeating would be right about there. Let me get a pen. Well, I guess you can see that point. Yeah, that shows up well enough. There's -1 and 2.6 repeating. Notice I went almost halfway, about halfway between the 0 and the 5 mark there. And then 0, 8 would be just under 0, 10. And then 124 would be just under the 25 mark. And now I can connect my points with that smooth curve that you see in your calculator. So that's the ready, set, go part. Let's take a look at the flip side, or that's the ready part. This is the set part. I'd like you to try and match these up on your own. See if you can tell what's happening in the story and what you're seeing in the graph, and we'll talk about them in class. Let's see if we need to talk about any of the go part. Here are our graphs, and here is go. Let's see if we can do the first one together. Most of these are solving equations in the way that we've been practicing in class, but this one looks a little bit different because x is in the exponent. And we haven't done any kind of algebra that would allow you to solve for that. So I'm just going to do some experimenting, and I'm going to make a table of values. And I'm going to say that when x is 1, y is 10. If I just put a 1 there, I get 10 to the first power, which is 10. If I put a 2 there, I would get 10 squared, and we know that's 100. If I put a 3 there, I would get 1,000, 10 to the third power, or 10 times 10 times 10. 10 to the fourth power would be 10,000. I'm essentially just adding a 0. And 10 to the fifth power would be the 100,000. And it looks like I have a match. When x is 5, I take 10 to the fifth power, I should get 100,000. So x has to be 5. So when you encounter a problem where x is in the exponent, it's that way in number 18, in number 20, and it looks like in number 22 as well. You're going to have to do a little bit of guess and check in order to figure out what your answers are there. That's it for 3.1, Ready, Set, Go. Have fun. Bye-bye.